Welcome to part 2 of Competency 10. In this video, we will answer questions relating to instantaneous rate of change. Number 1, what is the average rate of change for g of x equals negative x to the third plus 4 over the interval 1 to 6? Okay, so basically we're finding a slope. It's an average rate of change. Okay. So that's just a simple little matter of equation and putting it in the calculator. So what are we doing? Okay, we're talking about distance. So that interval, these are your x. So remember you want y over x. The change of y over the change of x. So this is an interval. So that would be 6 minus 1, okay? And then to get our y values, yes, you could substitute and go through all that, but I'm not going to. I'm going to use my calculator. So y equals, okay, I'm going to clear out what we have here, and minus x, caret up to the third, and then arrow over plus 4. Okay, now we go second graph. That gets us our table. Okay, so then what do we want? We want the value at x equals 6. So if you look here, that's negative 212. Negative 212. And then we subtract whatever the value is at 1, and that's 3. Okay, I'm going to put that in the calculator with parentheses here and parentheses here, as is. So I'm eliminating any possibility of mistakes. Now, here's another thing. I don't always do it in my videos. I like using parentheses, but we don't always have to. And you may see other videos where I use parentheses because I'm really fast at pushing that, okay? But you could say alpha window, arrow over, number 1, so you just push enter and it sets it up in a rational form. Okay, so I'll bounce between this or parentheses. Okay, so let's do this. Negative 212. Uh-oh, don't do that, don't do that, don't do that. You want minus 3. So first you put in the negative, but then after that it has to be minus 3. Negative 12 minus 3. Okay, now arrow down. And of course, 6 minus 1. Now let's push our enter and option B. Okay. All right, so what is the average rate of change at the function 2x squared plus 5 over the interval 2, 5? So it's the exact same process. So what I did is I put it in the calculator. So we have, right, we can clear out what we have so we don't get messed up. Okay, 2x and squared, just push your regular x squared, plus the 5. Okay, now second table. Okay, and we need this. This is what we need to put in the calculator. 5 minus 2, of course, that's 3. But then you go over to the value of 5, and that's 55 minus, now look at what the y value is for 2, and that is 13. Okay, you'll see it all there. It's right here, 2, 13. Then you go down to your 5, and that is 55. Okay, so we could put all this in the calculator as is, second mode. And what I like to do is if you want to do it like this, I'll go up and capture it. Now, this is a nice thing. When you look at, I'm highlighted on the denominator. Push clear. Ugh, too many clears. Never mind. Let's try that one more time. Go up. I'll arrow over. I'm going to push clear once. And it clears it out. I pushed it twice and it cleared everything. So let's arrow up. I'm going to go over. Clear. And it clears it out and you're fresh. So you can do it that way. Okay. So 55 minus 13, arrow down, 5 minus 2. Push enter. Okay, 14. And that is the correct option. Okay. Now, essentially, we're doing the same thing, but look at what the same means. Well, the interval has changed. Okay. All right. So we have from 2 to 3. So this will be 3 minus 2. Of course, that's 1, right? Okay. And then we know that because we have the same, it says, what is the average rate of change for, well, exact same function. We're just changing the interval from 2 to 5 to 2 to 3. Okay. So when x is 2, we know that that value is 13. So what do we need to do? We need to go back to our table since we already have our function entered. And we need 3. Well, 3 is 23. Well, I can already see that 23 minus 13 is 10, and that's over 1. So the value has to be option D, 10. Okay. But just to do it, we can just go up real quick, capture it, okay? And then you go over to the 5 and make that a 3, and then you go up to the 55 and make that a 23 and enter, and we get 10. Okay. Kind of recycling, I suppose. All right, so let's go. Oh, look, same function. Looks like they want us to practice with seeing the function over and over and as the interval changes. Number 4, what is the average rate of change? Same function over the interval 2 to 2.1. Okay, that is a bit of a difference. So, how are we going to handle that? That's a decimal. This is what we need to do. Okay, as again, just to show you, we still have the exact same function entered. That's fine. So we go second mode and we want to go second window. Okay, you can leave that on 1, but go down to where it says table. That's changing the table. And we have point 1. So we put point 1 in the change. That's the the how do I say, the value of x, how it's going to go in increments rather. Okay. So second graph gets us back to the table. And look, it's done what we needed. Okay. So let's go ahead and set this up. So we will have 2.1 minus 2. That's the difference in our x values. Now we need the difference in our y's, okay? So we know that 2 is still 13, and that's actually in our calculator. However, we need to know the value at 2.1. Well, if you just arrow down a little, there it is. That would be 13.82. Okay. And yes, you can see by doing this in our head, we have 0.82 over point 0.1, which I'm looking at the decimals. There's only one, I mean, the options. There's only one solution, one answer option, which would be B. But not a big deal. Let's just go back. Second mode, go up and capture, bring it down, and let's put this in. 2.1 minus 2. I'm in the denominator. Let's go to the numerator. Notice it types over, okay? 13.82 minus 13. And is it correct? Yes. Push enter. And there we go. Okay? It is correct. All right? Now, and let's go down just a little. Okay, same function. However, they're asking something completely different. For the function 2x squared plus 5, what is the instantaneous rate of change at this point? Okay, instantaneous rate of change implies first derivative. And there's a couple ways to get this done. Yes, we could use the chain rule and we could substitute the -4 in, but I'm not doing that. I already have that function I need entered. This is what I'm going to do. I'm going to go back out and I am going to say, I'm going to put my graph on. Okay. Now I need to say second trace because I need the blue, the calc. I'm going to go calc. See number 6 right there. That's the first derivative. So I'm going to say number 6. Okay, it's highlighted. See it blinking, blinking, blinking. Okay. I don't want to do any, and it says at the top, calc derivative at point. That means calculate my first derivative at that point. So when you have it on the screen, I know that my x value I need is -4. I want you to type in -4 and push enter. And look at the magic. Right here above your x value, it gives you the derivative. Okay? And that is -16, option C, and that is the value we're looking for. So now you know when you're asked for a first derivative off of a graph, you can just go to this screen if you know what you're doing, because it really doesn't tell you to do that. Okay? Now let's see if we can, let's try it again. Let's see if it'll do it again and again. And if not, then you have to go through the process. So let me see what happens here. -4, enter. It doesn't do it. You always have to go and push, but it does pop to -4 and tell us the y value is 37. Okay. All right. So we'll probably have a chance to show you that again. Okay. All right. Let's go to number 6. Number 6, for the function f of x equals 2x squared plus 5, what is the equation of the tangent line at x equals 2? Okay, first, the minute I hear tangent line, I know that I'm going to need the slope, okay? And that also tells me that they're giving me the value of x because they want the only way I can do that quickly and efficiently is to use the chain rule to get the first derivative of the equation and then evaluate that at 2, and that will give me my slope. Okay, and then I proceed to get my line. Okay, let me show you what to do. We need f prime of x equals, okay, that will be 2 times 2. That's just 4x because for uh, term by term, the first derivative of 5 is 0. Okay, now let's evaluate that at 2. That is 4 times 2 equals 8. So my m value, my slope is 8. Now I just apply the equation of a line using my values of x and y. I do not need to calculate that. What I do, I have my equation still in my calculator. I say second graph for my table, and I see that 2 is 13, which we knew from prior calculations. So this is what we do. We just follow through with y minus the 13 equals the slope of 8. And now I apply my x minus 2. So that becomes y minus 13 equals 8x minus 16. Add 13 to both sides. Those cancel. And y equals 8x minus 3, which is option C. Okay. All right. So now we're going to look at number 7. Okay. It says, what is the instantaneous rate of change of the point g of x for the function -x to the third plus 4? That's our g of x. Okay. So what we need to do here is we need to go back to our y equals. We're done with, and if you look at 7, 8, and 9, we're using the same equation. So we can cancel that out. And let's use negative x squared and plus the 4. Okay. All right. And let's populate that and let's go ahead and graph that. Okay. Nice. All right. That's what it looks like graphed. And that will also get it into our table. All right. We're going to have some problems with that. Okay. Now, this being said, we need to instantaneous rate of change. That definitely tells me first derivative. And I need to find that equation, and that's what number 7 is asking, okay? So that would be our, I'm going to, here, let me write it correctly, I'm sorry. Okay, that would be g prime of x using the chain rule, negative 3x, and that's squared, okay? And plus 4 would become 0. So the only thing that matches is option B. Now, look at C and D. You automatically know those aren't going to work. When we apply the chain rule, we don't just simply change the negative and positive. And if you have a constant, when you apply the chain rule, they're always 0. So when I looked at this, I already knew I wasn't even going to look at those. And the difference is we don't just, I mean, for A also, we do not just take off the negative. That isn't how we apply the chain rule. Okay. All right. For number 8. For the function, same function, what is the instantaneous rate of change at the point where x equals 0.5 or a half? Well, we already have that. We have found the first derivative. So all we're doing is doing the step of this. We're just evaluating. 1/2 equals negative 3, 1/2 squared. And this will become negative 3 times 1/4. Okay, I just squared. 1 times 1 is 1, 2 times 2 is 4. Okay, well, that's just negative 3/4. Okay, which is C. Okay, now we could put this, we already have this in our calculator. Let's look here. Okay, so uh-oh, I applied that wrong. That should have been, I pushed 2 instead of 3. Now let's look at the graph. Okay, I should have seen that automatically. That other graph didn't work. Okay, now you see where you can make mistakes. This is something to the third power. I should have seen that the minute it was negative, it kind of flipped around. And of course, plus 4 means a shift up. What we had before was something quadratic shifted up. And I saw it, I knew it wasn't right, and I thought we'll come back to it. Now you know that double check what's in your calculator. Now that we've done that, okay, we have the right graph. How could we get this the way we want? Remember, we did this before. Let's go second calc and go down to number 6. That'd be your first derivative, okay? And when you're there and it's flashing, we want negative, no, not negative. Oh, sorry. We want 0.5. So I am going to put in 0.5. See how it highlights up? And I'm going to push enter. Now look up at the top where it has the first derivative. It says negative 0.00. That 00 point, that one thing is always out there, but that is negative 0.75 is negative 3/4. Okay, same difference. All right, so that is the correct value. Now that we have that, and we've proven it to ourselves with our graph and put it in the calculator. Now it says for number 9, for the same function, what is the y-intercept for the tangent line at 0.5, a half, and 3.875? Well, that's 3 7/8, by the way. Okay, so we need to know what the y-intercept would be. Okay, well, we need to form the tangent line. All right. And I can tell you right now by looking, that's what I was kind of hesitated. I'm looking at these options and 0.5 and 4. Well, I know that just can't be it. Just notice that this is the intercept here, and that's what's in our graph. Their graph, that's 4. That's the y-intercept is 4. So I not believe in these. I'm not buying A and B. I'm sorry. I think that they're trying to sell me some oceanfront property. I don't know. Okay. But C and D, I'm not feeling D either. So I'm thinking I may have to go with C. Well, what's one reason why I know I have to go with C? It says y-intercept. And by definition, y-intercept is something 0, then you need a y value. So these answer choices are kind of dead giveaways, saying it's C, but let's go through the motions and do that. Okay. All right. So they say, what is the y-intercept at? So this is what we need to do. We need to say, here, I'm going to make a little bit of room for myself. I'm going to go up a bit so I can write. And there we go. So let's do the line, okay? And we need to know what our B value is. So I'm going to go back to the graph of this, and we need the value at a half, okay? So I'm going to go second window, okay? So I can change this to 0.5. I need increments of a half. And then I'm going to go just to 1 to make it easy. Now, second graph. Here we go. And look, there's, and that's they've already given me my value. But look, what I wanted to do is really show you how it's very convenient. You can get your values going on here. Okay, so this is what we're going to do. Y minus 3.875 equals, now I have my slope from number 8. That's my slope. That's my M. Actually, I could be a little clearer if I said M equals, just like I did before. Okay, so that is negative 3/4 and X minus a half. And I am going to do something particular here. I'm going to say that this is 3 and 7/8. Okay. All right. All right. 3 and 7/8 equals, because this is how my brain works. And I want to show you. Don't, how do I want to say this? Don't always shy away from fractions. They're great. If you know how to use them, you get used to it. I know when I teach, the kids just hate them. Okay. So y minus 3 and 7/8 equals negative 3/4 x. So a negative times a negative is a positive. I'm multiplying these fractions across. So all I have to do is 3 times 1 is 3. Numerator to numerator, now denominator times denominator. And 4 times 2 is 8. Now there's a reason why I want to do that. We are adding 3 and 7/8 to, oops, I don't want to do that, to both sides, okay? Plus 3 and 7/8. I could do better there. Okay. Plus 3 and 7/8. Okay. All right, now, let's look at this. Obviously, here, I need to change my pen color there. Okay. Obviously, this cancels out. Ooh, I have been playing around. Okay. And then that means that I have Here, let's see if I can scoot up a bit. Okay. That means I have y equals negative 3/4 x plus. Well, 3/8 and 7/8. That will be, I see 3/8 and 7/8. That's 10/8. So that means that's 1 1/4. Okay. Oh, so that will be 4 1/4. 4 1/4. Okay. You see what I did? I take 3/8 plus. I know it's me. You don't have to do it like that. You could just pop it in the calculator, and I will for you. So that would be 10/8. Okay, so that'll be 1, and then that's 1/4. Okay, don't worry about all that. That's me. And usually in my videos, I don't do anything in my head. That's just way my brain thinks. But we're not going to, because honestly, when I'm taking a test, I don't do that either. I'm not going to lie. So this is what we need to do. Let's pop it in like this. 3 divided by 8. Okay. Now we're going to add that to, okay, let's do it like this. Alpha window. Okay, see number 2? Let's do number 2. Ah, there you go. 3. This is just another way for me to show you stuff. So I have 7/8, right? And let's push enter, and there we go. And that is 4 1/4. Okay. I wonder what happens if we push math, enter, fraction, enter. Okay, it just gives us a 17/4. All right. And we could find that. We could say alpha window and pop over and go down to number 3 and go enter, enter. 4 1/4. So there's all kinds of way to play around with those fractions. It doesn't matter what have I discovered. I have discovered that if you want a y-intercept, make this 0 here, x would be 0, and then our intercept for our y value is 4 1/4, and that is correct. The only thing that works is option C. I know that was a long way around to get to answer, but it was an opportunity to show you some use of fractions, how to play around with it in your calculator to verify the correct answer. Okay, and number 9 is our last question in this video. And I really hope that you're getting something out of the videos, even though I'm long-winded sometimes. I tell you extra things. I honestly hope it's helpful for you and that it will help you pass the test and ease your mind a bit. Okay, and once again, I so appreciate all the likes and the sharing. I've noticed the numbers going up. You guys are awesome. And the subscriptions have gone up. Thank you, thank you, thank you. So don't forget to keep liking, keep sharing, and encourage someone else to subscribe. Okay, happy testing.